Let's take a look at the questions on homework number 14. The first topic is creating a scatter plot from a data table. And in this activity, you will need to take these x and y table values and plot them all on this coordinate plane here by following the x coordinate and the y coordinate. Okay, I've taken the time to plot all 8 of the data points. And now it's time to answer the question down below. The scatter plot shows a type of association. Now, a type of association has to do with the general trend of the yellow dots. Are they trending positively upward or negatively downward? Ours are trending positively upward. And that's because as you read from left to right, as the plotted values of x increase, so that statement will always be there because we read from left to right. So as the x values increase, the y values also increase. That's how you get a general trend positive. Let's take a look at another question. Again, I'm going to plot these 8 data points. Once the data points are plotted, you're going to kind of think to yourself, as you're reading from left to right, are the dots scattered everywhere? Or could you kind of draw a pretend line through here, like a line of best fit, where half of the dots are above and below it? And if you can, then that diagonal line would indicate a type of trend. So this one's very weak, but it is positively growing. As the x values increase, the y values are also generally increasing. You'll be asked to do this 3 times and choose from these drop-down menus. The second category, association and correlation, is where they plot the data values for you, and you merely choose what type of correlation they have. So if they have a positive linear correlation, which is shown up here on the screen, or a negative linear correlation, you can choose these first 4. They have these exceptions where you can have an outlier. And then they have this feature down here where it could be a pattern, it's just not a linear pattern. And then there's the option of no, which means that there would be no pattern at all whatsoever. So if we were to construct an imaginary line of best fit here, then we can say that that generally trends along a straight line or linear pattern. So we're going to choose positive linear, and there are no significant outliers, and it's generally, the y values are generally showing an increase, and that's why I chose positive. So this word here is going to match the trend of the option down below. Let's try this one more time. Again, if I were to construct an imaginary line of best fit, it is linear-ish. It does have an outlier here, so I'm going to choose positive linear with 1 outlier, and these values are generally increasing. This one, when I draw my line of best fit, it appears as though it's going negatively, again, with 1 outlier here at the bottom. So I'm going to choose negative linear with 1 outlier. And as we read from left to right, the y values are decreasing. All right, let's go back and take a look at the third topic, which is interpreting a line of best fit. In this question, you'll be asked to use that prediction line, that line of best fit, to answer one of these questions. Hunter's math teacher plots the students' grades on their weekly quizzes against the number of hours they study on the pair of coordinate axes below. They drew the line of best fit, and they want to know what is the meaning and context of this ordered pair, 2.5 and 81.6. Well, remember, this is the x value and this is the y value, and the x value represents time spent on homework, and the y value represents their quiz score. So if you were asked to interpret that meaning, then we can say, we can expect a quiz score of 81.6 if you study for 2.5 hours. So let's take a look at our options down here. After studying 81.6 hours, nope, that can't be right because 81.6 was the test score. A student who actually spent 2.5 hours studying and got a score of 81.6. All right, let's look at this word, this phrase here, I should say. Actually spent 2.5 hours. So only the yellow dots are the actual numbers. This word, expect, would be a point along the black line, not a yellow dot. Right? So this yellow dot would be actual values, and this green dot here, right, would be an actual value, because an expected value would be along the trend line. So we're going to choose here a student who actually spent 2.5 hours studying, got a score of 81.6. Let's try another one. So in this one, they're plotting the times the species of cricket will chirp in 1 minute, depending on the temperature. So they're asking us, what is the meaning of the x value when y is 95? What is the meaning on the x value, so what does this mean, when y is 95? So here's a y value of 95. What does that represent? 95 degrees. So if I have 95 degrees, then I'm going to determine how many chirps per minute the cricket had. So let's go down and read the choices. The actual number of times the cricket chirped when it was 95 degrees is our first option. The actual number of times the cricket chirped when it was 201 degrees Fahrenheit. Nope, we already determined it's going to be 95 degrees Fahrenheit. The number of times the cricket could be expected to chirp if it's 95, and the number of times it could be expected to chirp if it's 201. All right, so the question is, if it's 95 degrees outside, and we want to know how many times the cricket chirped, we would have to go from along this trend line until we reached 95. Now, do we have any data on when it's 95 degrees and how many times the cricket chirped? No, we don't have any data there yet, so that would be an expected value because it's not one of the currently plotted yellow dots. Let's take a look at this question. Mackenzie keeps track of the number of people inside a music hall to attend a concert by looking at the number of scanned tickets. She plotted the data on the graph below, where x equals 0 represents 6 p.m., and then drew a line of best fit. What does the point 1.25, 142 represent? Well, again, this is the x and y values, and the x is the time after 6 p.m. And the y is the number of people. So what does 1.25 mean? Well, after 6 p.m., 1¼ hours would be at 7:15 p.m. So at 7:15 p.m., there were 142 people in the music hall. At 7:15 p.m., there were 142 people at the music hall. Let's take a look at these options. At 1:15, nope. At 1:15, nope. At 7:15, there were exactly, or at 7:15, there were approximately. So we're looking for this data point in green here. Is it on the prediction line? No. So that means it's an actual data point. The prediction line would be approximately, but this green dot is exactly. Lamont has a part-time job at an ice skating rink selling hot cocoa. What does the line's y-intercept represent? So the y-intercept is here. It would be this value of approximately 0, I don't know, looks a little past 115, maybe 117-ish. But again, this is the temperature, and this is the number of hot cocoa. Are there any data points at that location? No. So this is a predicted or estimated value. Predicted or estimated value. That when it's 0 degrees outside, he will sell 117 cups of hot cocoa-ish. So we're going to come down here and take a look. Anything that says actual would be incorrect. So there are no actual data at that point. But it is a prediction of the temperature when 0 hot cocos are sold. Nope. A prediction of the number of hot cocos sold when the temperature is 0. All right, let's take a look at the linear regressions. Now for this question, they're going to ask you to calculate a linear regression equation that represents the data in this chart. And you can use the Delta Math calculator, or you could use your TI-84. I recommend doing at least 1 or 2 on your own graphing calculator. So you have to answer 3 questions in this section. So I would say you can do the first one here on Delta Math, but you should use your own calculator for the next 2 questions. So let me show you how to use the Delta Math calculator. So first you would click here to copy the values. Then you would open the statistics calculator. Once it was open, you would paste the values and then change over to the calculation menu. There in the submenu, you'll choose the second option, linreg AX plus B. I'm going to turn the diagnostics on just in case I need a correlation coefficient when I get to the question. Choose calculate, and here are your values. The question asks you to round to the nearest, let's take a look here, rounding all coefficients to the nearest 100th. I'm going to go back and take a look. Oops, sorry, here we go. And it looks like my values only go to the nearest 10th. So y equals 42.2x. So y equals 42.20x. That's the nearest 100th. And then this b value was 947.6. Was 947.60. Using this equation, find the projected number of new cases for 2014 rounded to the nearest whole number. Right, so this is my prediction equation, and they want to know how to find the projected number of new cases for 2014. But you'll notice the years aren't written as their actual values, but how many years they are past the number 2014. I'm sorry, past 2004. So since I want 2014, that means I want 10 years from now. So I want an x value of 10. So here's my prediction equation. And I'm going to erase and replace my x value with a 10. And now all I need to do is pick up my calculator to compute. I'm going to use a basic calculator this time. So I'm going to do 42.20 times 10, and then I'm going to add 947.60. Oh, I messed up. 42.2 times 10 plus 947.6, and I get 1,369.60 if I'm rounding to the nearest 100th. But this one said to round to the nearest whole number. So this is the whole number place. The number after us would round us up, so that would make this 9 a 10, carry the 1, I would get 1,370. So let's type that here and submit. Let's take a look at the next topic on exponential regressions. So you're going to do the same thing as before, except this time, instead of computing a linear regression, once you've copied your values or entered them into your TI-84, you are going to calculate number 0, or exp reg. On your TI-84, it's exp reg. So I am going to turn my diagnostics on, right? Always keep them on in case they want to know about the correlation coefficients. Even if they don't, it's good to have it on. So here are my values. This is my A value. This here is my B value. And we need to go back and take a look and see what they were asking for. And it said here, using this equation, round all coefficients to the nearest hundredth, and then compute the value of the car if your X value, or your years, is number 8. So let's go back to that screen that had our equation on it, and we're going to round our value to the nearest hundredth. So our equation is going to be 14207.35. Our B value is going to be 0.88. So this is our exponential equation. And then what we're going to do is we're going to need our calculators, and we're going to compute this with the number 8 right up there in the exponent position. All right, so I'm going to leave this ink on the screen while I go back here so I can type it without messing up. And it is y equals 14207.35, parentheses 0.88. I'm going to choose Shift 6. Oops, not an X. This is an X. So when they want the equation, they want it with the X. And then when they want the final answer, they want it with the 8. So let's open up our calculators. Alright, got my handy dandy calculator here. I'm going to type my sentence of 14207.35, parentheses 0.88, exponent of 8. And again, it's going to ask me to round to nearest cent. Cent is the hundredths place, or $5,109.45. So $5,109.45. So now I can take my ink off and give it a go. Alright, again, you're going to copy these values into your stat, edit, list 1. Right, so here we're going to write 0, 1, 2, 3, 4. And then in our list 2, we're going to put our values, 16,900, 14,916, 13,377, 11,062, 9,994, double check. Now this time stat calc, you need to arrow off the screen all the way to number 0. exp reg. There's my values. They ask us, in this problem, rounding all coefficients to the nearest hundredth, using this equation to determine the value of the car to nearest cent after 9 years. So I'm going to type the equation here, y equals 17041.85, parentheses, 0.87, parentheses, shift 6x. Now, I can compute it on my main screen, or I can just look at these. Whoops, I can put it in my y equals and look at the table. But I'm just going to go to my main screen here and compute it. Let's see, 1704.25.87 to the 9th year, rounded to the nearest cent. So 4866.20. All right. Let's go back and take a look at correlation coefficients. And what we have here, or sorry, was it? Yep. What type of correlation is represented by this scatter plot? You'll see it is trending positive It is very weak. I'm sorry. It's very strong because the dots are very close together, but it's not perfect because it's not straight, so we're going to call that a strong positive correlation. Again, one more time. This dots are very close together, so that's strong, but they are going down, so we're going to call that a strong negative correlation. And then this one is a strong positive, but definitely not perfect. Perfect would be something like this. Perfectly straight, long line that's a perfect negative correlation. All right, last topic. Strength of linear relationships. So here are 4 calculator regressions, and they're asking us which one represents the strongest positive linear relationship. So we need to look at these R values. The only way to tell what the relationship is like is to look at this R value, or the correlation coefficient. The first thing we're looking for is positive. All of these are positive. Oh, that one's negative, so that one's out. Next thing we're looking for is strong, and you cannot be over 1, so that one's out. This is a 0.12, this is a 0.67, so that makes this one the winner of the group. So we're going to say regression equation 2. Again, for each of these, you're going to look solely at the R values and choose what they're looking for. Strongest, positive. That's negative, and this one is stronger than 0.28. So the answer for us is regression equation 3. And that will finish off homework number 14.